Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Alright, we are told to find the measures of the numbered angles in rhombus ABCD. The rhombus part is important because it tells us that we can use the rhombus diagonals theorem and the rhombus opposite angles theorem. So, first, measure of angle 1, we immediately know is 90 degrees because the diagonals of a rhombus are perpendicular. Perpendicular means 90 degrees. All right, measure of angle 2 and the measure of angle 3 are the same. And in fact, they are the same as the 72 of angle DCA. So, these angles are both 72 because opposite angles are congruent and diagonals bisect the opposite angles. So each of these four angles, angle 2, angle 3, angle 72, and angle BCA, are all 72 degrees. All right, and lastly but not least, the measure of angle 4. Now, measure of angle 4, there are many different ways that we can find this. One is by figuring out what the whole measure of angle D is and dividing by 2. Another way is by looking specifically at this triangle and noticing that we have the measure of angle 1, the measure of angle 3, and the measure of angle 4 all in one triangle. And the degrees within a triangle always add up to 180 degrees. So we can take 90 plus 72 plus the measure of angle 4 equals 180. 90 plus 72 is 162 plus the measure of angle 4 equals 180. Subtract 162 from both sides, and we get that the measure of angle 4 is 18 degrees, which makes sense because it looks pretty small, right? Looks pretty teeny. All right, wonderful. We found the measure of angle 1, 2, 3, and 4, so we are done. And let's move on to what we have for today. So today we're continuing in section 7.4. We're continuing our conversation about special parallelograms. Today our focus is on rectangles. So our learning target says you remember what rhombuses, rectangles, and squares are, so you know what these special parallelograms are. Our success criteria for today is that you can use properties of rectangles to solve problems. So now we're looking more specifically at rectangles. Okay, so before we jump into specifically rectangles, let's review. A rhombus has 4 congruent sides, a rectangle has 4 right angles, 4 congruent angles, and a square has both. So a square is a rectangle. So when we talk about properties of rectangles today, these properties are also true for squares. Just like when we talked about rhombuses in the last video, all of those properties were true for squares as well. So, quickly, a rhombus is a quadrilateral if and only if it has 4 congruent sides. A rhombus is a type of parallelogram, just like we learned about yesterday. A rectangle is, a quadrilateral is a rectangle if and only if it has 4 right angles. So that's what makes a rectangle is the 4 right angles, nothing else. Well, okay, nothing else is necessary. And a rectangle, of course, is a type of parallelogram. And a square, a quadrilateral is a square if and only if it is a rhombus and a rectangle at the same time. So remember, a rhombus is a rectangle, or excuse me, a square. A square is a rhombus, and a square is a rectangle at the same time. So, a square has 4 congruent sides and 4 right angles, and of course it is a type of parallelogram. I'm going to show you this screen again as well. All of this so far has been a review from yesterday, but it's important for what we're talking about today. Remember that squares are a type of parallelogram. They are also a type of rhombus and a type of rectangle. So a square is everything within this box. A rhombus is a type of parallelogram because it's within this box. And a rectangle is a type of parallelogram because it is within this box. We can have rectangles that are not squares. We can have parallelograms that are not rectangles, but we cannot have a rectangle that's not a parallelogram. Every rectangle is a parallelogram, and we can't have a square that's not a rectangle. Every square is a rectangle, but not all rectangles are squares. Okay, awesome. If this information is not in your notes, make sure that it is. And if you like this diagram, put that in your notes as well. I think this diagram is super, super helpful. Okay, so specifically today, we're talking about rectangles. So we're going to start off with the rectangle diagonals theorem. Now, the rhombus diagonals theorem said that the diagonals met at a perpendicular, or they met at a 90-degree angle, or they were perpendicular. But the rectangles diagonals theorem can't say that. That's not a 90-degree angle. What does the rectangle diagonals theorem say? It says a parallelogram is a rectangle if and only if its diagonals are congruent. So what this tells us is if I have a rectangle, then the diagonals are congruent. They are the exact same length. Not only are they bisected, right, because all parallelograms, the diagonals bisect each other, but we can take it a step further and we can say that BD is exactly the same as AC. AC and BD are congruent. So if we have a rectangle, then the diagonals are congruent, and if the diagonals are congruent, then we have a rectangle. So that's what the if and only if part of this theorem means. Okay, so diagonals must be congruent in a rectangle. Let's do an example about identifying rectangles, and then we're going to use this theorem we just saw as well. So, you are building a frame for a window. Interesting. Okay, so we're building a window in a house. The window will be installed in the opening shown in the diagram. So the window's going to go here in the opening. The opening must be a rectangle. That makes sense. Windows are rectangles, typically, so we need the opening to be a rectangle. Given the measurements in the diagram, can you assume that this is a rectangle? So let's see. We have 44, 44, 33, 33. So the opposite sides are congruent, but does that mean that it's a rectangle? Well, in a parallelogram, opposite sides are congruent, but remember, a rectangle needs to have 4 right angles. That's what it means to be a rectangle, is that we have 4 right angles. We don't know. We don't know if we have 4 right angles or not, so no. We don't know if this is a rectangle because we don't know if the angles are 90 degrees or not. We know that it's a parallelogram. Opposite sides are congruent. It's a parallelogram, but we don't know if it's a rectangle specifically. Okay. And for part B, we measure the diagonals of the opening. The diagonals are 54.8 inches and 55.3 inches. Now what can we conclude about the shape of the opening? Well, now we know it is not a rectangle. How do we know that? How do I know that it's not a rectangle? If the diagonals are 54.8 and 55.3, it's not a rectangle. Because if the diagonals are congruent, then I have a rectangle. If I have a rectangle, the diagonals must be congruent. So if my diagonals are not congruent, I can't have a rectangle. It is not a rectangle because the diagonals are not congruent. Let's see if we were correct. No, you cannot. The boards on opposite sides are the same length, so they form a parallelogram, but you do not know whether the angles are right angles. That's exactly what we said. By the rectangle diagonals theorem, the diagonals of a rectangle are congruent. The diagonals of the quadrilateral formed by the boards are not congruent, so the boards do not form a rectangle. Yay! We were correct. Okay, now we have another example that we're going to do. In this example, we want to find the diagonal lengths in a rectangle. So we're told in rectangle QRST, so that's important. We know that this is a rectangle. We know QRST is a rectangle. QS, let me color code. QS is 5x minus 31, and RT is 2x plus 11. Find the lengths of the diagonals. Well, I know that the diagonals must be equal to each other. They have to be congruent. So QS and RT, the diagonals must be the same. And let's see, QS is 5x minus 31, and RT is 2x plus 11. So I need to figure out what x is. Then when I find out what x is, I can plug them in. I know that QS is 5x minus 31, but what is that? What is that in numbers? I want it without x. So let me solve for x, and then I can plug it in, figure out what QS is. All right, so let's see. I'm going to subtract 2x on both sides. We get 3x minus 31 equals 11. Add 31 to both sides. 3x is 42. Divide by 3 on both sides. And x is 14. 14. Now, the question did not ask me to solve for x. The question asked me to find the lengths of the diagonals. So now I need to plug this x in and figure out what is QS. 5 times 14 minus 31. 5 times 14 is 70. Minus 31 is 39. So QS is equal to 39. Oh, but QS is equal to RT. So they both must be 39, because remember, the diagonals of a rectangle are congruent. So if one of them is 39, they're both equal to 39. Let's check and see if we were correct. QS is equal to RT. Set it equal. X equals 14. Plug it in. 39 Each diagonal has a length of 39 units. Now, notice they plugged 14 into QS and to RT, but you don't even need to do that. You know the diagonals are congruent. I suppose you could check. You could check and make sure by plugging it into both, but you don't have to do that. Although checking is a very good idea. Okay. That is what I have for you today. Lot of the beginning was a review from yesterday. Rectangles, rhombuses, and squares. And then the theorem that we learned about today, the rectangle diagonals theorem, was specific to rectangles. So, at this point in time, assess your understanding of the learning target and the success criteria. Where are you at? Do you remember the difference between rectangles, rhombuses, and squares? Do you remember what they are? And can you use properties of rectangles specifically to solve problems in geometry? So, depending upon how you're feeling, take the appropriate action. Maybe you need to ask some questions. You need to ask your teacher for help or a friend for help. If you're a 2, you think you got it, it's time to try the homework and see what questions arise and see what you're confident in. And if you're a 3, hey, when you finish the homework, think about helping your classmates or helping a friend, reaching out, seeing how they're doing with their homework. Okay, here are some practice problems that you can do to practice the skills that you have learned in this video. And yeah, try these. Of course, do the homework that your teacher assigns as well. Now, let's end our video with a launch. Today's launch comes from Amy Poehler. If you've seen Parks and Rec, you know who Leslie Knope is. And Amy says, take your risks now. As you grow older, you become more fearful and less flexible. Now, more fearful, I think, goes hand in hand with less flexible. And when it says more fearful, it doesn't mean that, like, oh, as you get old, you get scared. Like, and that's how life works. What this means is that, you know, as you get older, it's harder to take risks. Because you've assumed more responsibility, right? When you're living with your parents and they provide you food and shelter and things, you have a little bit more freedom to experiment and try different things that you want to do. Once you are paying your own rent, paying your own bills, it's a lot harder to, you know, try something crazy that you want to do. Like, for example, when I was in high school, I really wanted to be on Broadway. And I tried, you know, I did high school musicals, the musicals within my high school, but I never really branched out and tried to do more than that. Now, if I wanted to try to go do more musicals or be on Broadway, I'd have to quit my job or stop working, you know, or I'd have to work less. I'd have to find a different job because I still have bills to pay. So I can't just quit my job, you know, and try musicals. But when you're in high school, when your parents can still help you financially, that is the time to be in every musical that you want and to learn how to dance in every way and how to learn how to sing in every way so that you have the skills that you need to pursue Broadway in the future. Or if you want to be a professional soccer player, now is the time to, you know, reach out to professional sports teams and practice really hard and get on better teams so that you can get noticed. Because as you get older, it's not that you just get, you know, oh, because you're old, you get more scared. It's because you've assumed more responsibility. So whatever risks you're wanting to take, whether it's becoming a professional athlete, being on Broadway, whatever the risk you want to take, try it now. Because as you get older, it gets more difficult to go after maybe some of those dreams that you have. So whatever those risks you want to take, think about them now and maybe make a plan for how you want to tackle them if you truly want to tackle them. But that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.